So understanding of speech depends upon the auditory column receptor fields directly detected in sounds having the ability to indirectly activate visual receptor fields on the basis of frequent past simultaneous activity. And this creates a pseudo-visual subjective experience in which the active receptive fields have many of the recommendation strengths appropriate to the actual presence of the corresponding visual situation. This pseudo-visual experience is largely constructed from fragments of the column activity during many past sensory experiences. And as I stressed before, the experience falls well short of an actual visual hallucination. The construction of these pseudo-visual experiences depends upon sequences of behaviors, but these behaviors act back on the brain itself. Nevertheless, the behaviors have to be recommended by cortical receptor field detections, selected by the basal ganglia, and implemented by the thalamus as information releases between cortical areas. In addition to releases from one sensory area to the next, there are releases to and from areas with receptive fields defined by simultaneous activity of various groups of columns. And these types of releases implement what we've been calling indirect activations and activity prolongations. These sequences must be learned through rewards. In other words, in the infant brain, recommendation strengths in favor of different release behaviors may be relatively random initially, but sometimes a good combination of release behaviors happens to be selected. Receptive fields detected in the infant's brain within sensory perceptions of adult behavior in response to the infant's attempts will recommend rewards, and the recommendation strengths in the basal ganglia in favor of different types of releases will be adjusted until appropriate sequences are almost always selected. Once a sequence has been used successfully a number of times, it'll tend to be recorded in the cerebellum and be implemented much more rapidly when it's needed. And note that the appropriate sequences are learned, and different sequences could sometimes achieve different results. Different languages use different sequences of brain activations, which are reflected in the different syntaxes used. To describe a man stroking a cat, in which the man is the subject, the verb stroking, and the object is the cat, in English, the most common word order is subject, verb, object. But in Basque, the language spoken in Europe on the border between Spain and France, the predominant word order is subject, object, verb. We've already described the sequence of behaviors supporting the subject, verb, object order, such as dog chases cat. So if we look at the processes supporting the Basque word order, visual columns are activated in response to hearing gizona, the activity of those columns prolonged, and more columns activated in response to hearing katua. Then both these populations are prolonged, and several populations activated in response to hearing the word trazu. It's only at this point that a sequence of synchronization and release behaviors is initiated to generate an endpoint visual population similar to the verbally described scene. There could be advantages of some word orders over others. For example, if the number of independent populations of columns that need to be maintained active at the same time in the same cortical area, if that's a bit lower, that could be an advantage. And this type of consideration could be the reason some word orders are much more common than others. If we consider the phrase David chasing Mark, in English, the subject David comes first and the object Mark comes last. But there's half a dozen possible orders. And most languages predominantly use the order subject, object, verb. Japanese is one example. Other languages like English predominantly use David chases Mark. And in fact, these types of languages that usually use the subject, verb, object order have the most speakers. So these two types of orders are very much the majority, and the predominant use of some other word orders is almost non-existent. Ixcariana and Wario are languages spoken by small groups in South America, and their predominant use of these word orders is naturally certain. So probably the predominance of certain word orders indicates that these word orders are easier to handle with the physiological information processes that are available. But there are some other cues or situations in which receptive field detections can influence the sequence of activations, prolongations and releases to generate appropriate end populations. And these other cues can include the use of pauses, stress or intonation, and they could provide a meaning to a different word order. For example, in English, there are pronouns, like he or him, and the pronoun is different depending on whether the object referred to is the subject or the object of the phrase. Him is used to indicate if it's the object, and he is used to indicate the subject. So the phrase he, him chases, object, subject, verb, rather than the more usual subject, verb, object, still can convey the same meaning. Receptive fields detected in the different sounds actually drive different activation sequences. Slightly longer pauses or changes in stress or tone can also signal changes in the information processing sequences to be used.